Hello, good day viewers. Welcome to another additional mathematics presentation. So in this presentation, I want us to answer this question 11 right here. So this is a question that came in additional mathematics paper 1 for 2023 internal. So this was question 11b. So we have this question that is coming from integration. So the question reads, the diagram shows part of the curve y is equal to x cubed minus 2x squared minus x plus 2 intersecting the x-axis at point A and B. So this is the diagram that is showing this curve right here, which is intersecting the x-axis at point A and B. So we have this function for this curve right here. So let us now look at the questions down here. So the first question is saying, find the x-coordinates of A and B. So we need to find the x-coordinates of A and B. So these points A and B, they are lying along the x-axis. So to find the x-coordinates of A and B, we are going to use this function that we have. So this function, it's along the line y is equal to 0. So where there is this y, we are going to substitute or to put a what? A 0. So how are we going to answer this question? So we are going to start with our question A. So our question A says we need to find the x-coordinates of A and B. So we can write our, so we take note of the function y is equal to x power 3 minus 2x squared minus x plus 2. So from here, what are we going to do? So what we are going to do is this. We have noticed that this curve right here is cutting the point A and point B along the x-axis. So this x-axis is the line where y is equal to 0. So we are going to equate this to 0. So we are going to write x power 3 minus 2x squared minus x plus 2 is equal to 0. So after coming up with this, now we can find the x-coordinates, okay? So to find the x-coordinates, there are many different formulas that you can use. So this is, you can see the highest value or the highest power of x, sorry, it's a 3. So we have x power 3 minus 2x squared minus x plus 2 is equal to 0. So number one, you can use the testing point method where you start substituting on the x values starting from 1 to see if it's going to give you 0. Okay, then the other one that you can use is look at the terms that you have 1, 2, 3, 4. There are 4, so we can try to factorize to see if it's going to be the same. Okay, so what we are going to do is this. We use the same way of factorization. So these are 4 terms. So we have x power 3 minus 2x squared. What is common here? So what is common here? It's x squared. So we are going to write x squared, open bracket, x squared into x cubed. We are going to remain with x minus x squared into 2x squared. So x squared and x squared you cancel, you remain with 2, you close. So whatever that we have here, even when we factorize here, we should get the same things. If they are different, it means we need to go back to our question and answer it in a different way. Okay, so minus here, you put a minus x plus 2. So here x plus 2, here you have x minus 2. So you can notice that what is common here is just a 1. Then open bracket, 1 into x, you get x. Negative times positive, you get negative. 1 into 2, you get a 2. Okay, then equal to 0. So you can observe that what is inside the brackets, even here, they are the same. Okay, so you can just take 1, which is x minus 2. Then we pick x squared minus 1. X squared minus 1 equal to 0. So again, here you can observe that you have, first let's equate x minus 2 equal to 0. This 0 first we solve for x. So we are going to have x is equal to 2. So this is the first value of x. Then you also have x squared minus 1 equal to 0. So this is a difference of 2 squares, which can be written as x minus 1, also x plus 1 equal to 0. So from here, if we equate x minus 1 equal to 0 or x plus 1 equal to 0. So we are going to have x is equal to 1 or x is equal to -1. These are other values of what? Of x. So generally here we can notice that we are saying therefore x is equal to 2, 1 or -1. So let's look at the question. They want us to find just the x coordinates of point A and B alone. Now when you notice the values that you have come up with, there is even a -1. X is equal to -1, meaning that when you look at this graph right here, once we do an extension like this, okay, it means that it was even coming to a -1. So that -1 we have found for x, it's also valid, but our focus is just on the positive x coordinates of A and B. So here it's x is equal to 1 and here it's x is equal to 2. Okay, so those are the x coordinates of point A and B. So I can just say therefore the x coordinates of A and B are 1 and 2. So this is our answer. So this one is for A, this one is for B. Okay, as you have noticed here on the diagram, here it's 1, here it's 2. So we have answered our question 1. Let us now move on to our second question right here. So this is our second question, which says find the area of the shaded region. So we come to this region. They want us to find the area of this shaded region and this other shaded region. So what it means here is that we are going to have two areas. There is this shaded region 1 and this shaded region 2. So we can name this as area 1 and we can name this as area 2. So we need to find area 1 plus area 2. Then we are going to have the total area of this shaded region. So what are we going to do here? So what we are going to do is this. Remember, we are saying area of the shaded region. So to find the area of this shaded region, this is what we are going to do. So to find the area of this shaded region, we are saying area of the shaded region, area of the shaded region is equal to, so we have said area 1 plus area 2. So this area 1, once we find the area 1, then we add it to area 2. So remember, this is the area of this graph, so we need to integrate this function. Let's not forget this function. Okay, so to find the area 1, we are going to integrate this function using the limits. Okay, so here we have 0 and here there is 1. So meaning that here x is equal to 0 and x is equal to 1. So this is what we are going to do. So for area 1, we can say area 1 is equal to, so we are going to find the integral of, so remember I've said the limits is from 0 to 1. So we are going to have 0, 1. Then we have this function which is x power 3 minus 2x squared minus x plus 2. So we need to integrate this function, then we substitute. Okay, so this is what we are going to do. So we are going to say area 1 is equal to, we have the integral of, so this one will be x power 4 over 4. So we know the basics of integration. So 3 plus 1 over 3 plus 1, which is a 4, minus 2. So this one will be 2 plus 1, which will be 3, again over 3, minus, so this one will be x power 2 over 2. Then plus, this one will be a 2x. So we know these basics. Okay, so from here now, what are we going to do? So what we are going to do now is we are going to separate these limits that we have. So we are going to say area 1 is equal to, so we'll get the same function, okay, which is x power 4 over 4 minus 2x power 3 over 3 minus x squared over 2 plus 2x. We put it in brackets. So this one is going to go with this limit 1. Then we say minus, again the same function, which is x, okay, x power 4 over 4 minus 2x power 3 over 3 minus x power 2 over 2 plus 2x. So this one is going to go with the 0, this limit right here. So we can now just substitute. So we say area 1 is equal to, so here we are using 1, so where there is x we are going to put 1, which will be 1 power 4 over 4 minus 2, then 1 power 3 over 3 minus 1 power 2 over 2 plus 2 and then a 1. Then minus, even here where there is x, we are going to put a 0. Okay, so this will be 0 power 4 over 4 minus 2 and then 0 power 3 over 3 minus 0 power 2 over 2 plus 2 and then 0. Like this. So from here, we can say area 1 equal to, so 1 power 4, it's 1, so you just get 1 over 4, minus, even 1 power 3, it's 1, so it will be just 2 over 3, minus 1 power 2, it's 1 over 2, plus 2 times 1, it's a 2. Now, for this one right here, 0 power 4 is a 0, even here it's a 0, even here it's a 0, even here it's a 0. So this one will give us a 0. So we say minus 0, this will go. Okay, so just focus on this one. So we just say area 1 equal to, so here we can just now use our calculator. Okay, all right, so once we punch all these on the calculator, this is the area 1 that we are going to get, 13 over 12 units squared. Okay, so this is just for area 1. So remember, we need to find area 1 and area 2. So area 1 we have found that is this value. Now let us find the area 2 according to our formula here. So for area 2, we are considering now this shape right here. This shape right here. So for this shape, which is between point A and B, so the x value here, x is equal to 1 and x is equal to 2. So we are going to use these as our limits. Then we are also going to use the same function here, but different limits, okay, for this shaded region. So we are going to say area 2. I hope this is clear for you now. So we are going to say area 2 is equal to, so the limits we have 1 to 2. Then we have this same function that we have x power 3 minus 2x squared minus x plus 2. Okay, so we differentiated, we integrated this function already. Okay, so there is no need for us to take time. So area 2 equal to, so we did mention that the integration of this, we had x power 4 over 4 minus 2x power 3 over 3 minus x squared over 2. Then we say plus 2x. So this is what we have. So the limits we have 2 and the 1. Okay. Then here we can now separate by using these limits that we have. So we have area 2 equal to, so we can write the same function here and substituting the first value 2. So we can have 2 power 4 over 2 minus 2 and then 2 in brackets power 3 over 3 minus 2 power 2 over 2 plus 2 power 2. Okay, so we can do this minus, so I've used 2 here, I'll get the same this one again. We'll say, so where there is x now we're going to put a 1, so this will be 1 power 4 over 4 minus 2, then 1 power 3 over 3, then minus 1 squared over 2 plus 2, then a 1. Okay, then we close. So we can say area 2 equal to, so 2 power 4, this gives us a 16 over yeah, supposed to be a 4 here, you can see, yeah, 16 over 4 minus 2 power 3, it's 8 times 2 also gives us 16 over 3, okay, then minus this one, it's a 4 over 2, then plus this one, it's a 4. So this is what we have. Then minus we can come to this one, 1 power 4, this is 1 over 4 minus 2 over 3 minus 1 over 2 plus 2. Okay, then we can just simplify. Area 2 can just simplify now. Okay, so I'll punch these on the calculator, and then minus, I also punch these on the calculator. Alright, so once we punch these on the calculator, 16 over 4 divided by 16 over 3 minus 4 over 2 plus 4, it gives us 2 over 3, then minus, again 1 over 4 minus 2 over 3 minus 1 over 2 plus 2, gives us 13 over 12. So 2 over 3 minus 13 over 12, this gives us this value right here. Okay, it gives us the negative, okay, I'm sure you are able to see, negative 5 over 12. So here we are going to say area 2 is equal to negative 5 over 12. Now don't leave your area with a negative sign, okay, don't leave your area with a negative sign. And one of the reasons why it's even giving you a negative, because you are finding this area, you can see below the x-axis right here where the value of y will be a negative. That's why you're having a negative. So you're just going to leave our area 2 in a positive form, okay, which will be written as, okay, which will be written as, we just say, therefore area 2 is equal to 5 over 12 units square. So remember, this is not our final answer. The first, we said we need to find the area of the shaded region, we need to add area 1 plus area 2. And we have found both area 1, which is this area, and we have found area 2, which is this area. Okay, so we are just going to add these two areas. We are going to say, therefore, area of the shaded region, okay, is equal to, we said, area 1 plus area 2. So what is our area 1? We have 13 over 12 plus, what is our area 2? We have 5 over 12. So we can add these because the denominators are the same. So this gives us 18 divided by 12, okay, of which we can leave it as a decimal number, it's fine. 18 divided by 12, okay, so this gives us 18 divided by 12. Okay, so this is the value, 1.5. So we can write our area as 1.5 units square. So this is the area of the shaded region. Okay, this is the area of the shaded region. So we have come to the end of our presentation. Okay, so if you have any questions, you are free to leave a comment in the comment section. I will be able to respond to you. So this is our question that we have answered. So here the x coordinates, we have said 1 and 2, and the area of the shaded region is 1.5 units square. So you can see that this question was carrying 6 marks, this one 2 marks. So thank you so much, everybody. We've come to the end of our short presentation. This has been your presenter, Mr. Mlenga. Bye bye.